There are charges all around us. This basketball has a charge. This tree has a charge. Even the sky has a charge.
Do I have a charge, Matt?
Yes, Nick, you do have a charge. Be a positive charge, a negative charge, or even a neutral charge. Everything on Earth has a charge.
Brought to you by electrons, keeping life charged for billions of years.
You can't resist it.
It's electric.
Boogie, woogie, woogie. You can do without it.
It's electric.
There are 3 types of electric charge.
Positive charge. Negative charge.
No, this one doesn't have a charge.
Charges interact in 2 ways.
The like charges repel or push away from each other. The opposite charges attract or draw closer to each other.
Electrostatic spray painting is a real-world example that utilizes the principle of attraction between unlike charges. Paint droplets are given a negative charge, and the object being painted is given a positive charge. When I rub the balloon against my hair, both the balloon and my hair become electrically charged. The rubbing transfers some of the electrons in my hair to the balloon, meaning that my hair is losing electrons and the balloon is gaining electrons. This gives my hair a net positive charge and the balloon a net negative charge, thus making the two attracted to one another.
Boogie, woogie, woogie.
Are you charged yet? Are you charged yet?
No.
How about now?
I feel charged.
The Van de Graaff generator charge is transferred from the belt to the dome by a belt that is kept in motion. The charge is deposited on the belt and then transferred to the dome. When Nick and Kelly touch the Van de Graaff generator, the electrons will transfer into their bodies, creating a buildup of negative charge. It is easy to see on Kelly that she has a buildup of charge because of her hair. The atoms in her hair have the same negative charge, so they want to push away from each other. Because there is nowhere else for the electrons to go, they push out as far as they can, making her hair stand up. Discharge is where the electrons have a convenient place to go with fewer electrons. The static electrons discharge or jump to a new site. Whoa. Shocking Nick was an example of discharge. Lightning is also a real-life example of discharge. Induction is the process of charging a conductor by bringing it near another charged object and grounding the conductor.
The negative charge transferred to the balloon by Matt's hair attracts oppositely charged substances without contact through induction. As you can see, the negatively charged balloon attracts positively charged pieces of paper, grains of sugar, and polar water molecules.
Oh, that's cool.
The magnitude of electric force depends on the distance between two charges. Because the pair of charges on the left is closer together than the pair of charges on the right, the pair of charges on the left has a greater electric force. The concept of electric force can be shown by Coulomb's law, where electric force is equal to Coulomb's constant multiplied by the quantity of the product of two charges over the square distance between those charges. Electric fields exist in the regions around a charged object. The lines of an electric field for a single point positive charge are directed outward, away from the charge and towards infinity. The lines are more spread out as they go towards infinity, indicating that the strength of the field becomes weaker farther away from the charge. Electric field lines for a single point negative charge are directed inward, toward the charge. This indicates that the strength of the field is greatest closer to the charge because the lines are closest together there.
These two videos represent the strength of electric forces. In this example, Kelly and Michaela have equal and opposite charges, so when they interact, their net force will be zero. Equal force between charges is shown by the same number of lines leaving the positive charge as are terminating at the negative charge.
Kelly and Michaela represent an electric force that is stronger than an electric force represented by Matt. As a pair, it is apparent that the two girls overpower Matt. This is similar to the net electric force on an atom in the way that the larger charge puts a greater force on the atom. Electric field strength depends on the magnitude of a charge and the distance of that charge to a specific point in a field. The number of lines is proportional to a charge's magnitude on a graph.
Just how it feels when I know when it's not, and I know when it's real. Yeah, it's hard to describe this feeling I got.
And see it.
It's electric.
You gotta feel it.
It's electric.
Ooh, it's shocking.
It's electric.
Baby, she's a boogie of the time. She's a boogie of the time.
She sure does the boogie.
You can know when
Everywhere. Too many charges.
It's electric.
Ah!
What are you doing? Go right above it and just
No.
like...
Fail.
Let's see if it